Hey there, in this video I'm going to go over solving multi-step equations. So you might be used to doing equations that take 1 or 2 steps to solve and that's it. So I'm trying to think of equations that might take 3 or more steps to solve. Okay, so here I have an x variable on both sides, and chances are if you struggle with algebra, anytime you see an equation with a variable on each side, you kind of start to panic. So the key thing is to just break it down. What do you need to go through? I need to get all my x's on one side, and I need to get all my other numbers that don't have an x next to them to the other side. And then you can, your third step, you can multiply or divide the number that might be the coefficient that's written right by the x. Okay, so let's go ahead and get started. So the first step I said was get all your x's on one side. So what I like to do is I like to see what number is bigger or smaller. I look for the smaller x, or maybe there's one with a negative sign. I get it over to the other side, so I'm working with positive x's. So 7x is bigger than 3x, so I'm going to move this 3x to the other side. Now I can't just move it. I have to do the opposite thing to get to the opposite side. There's nothing that says plus 3x or minus 3x, but if it just says 3x, it's saying that's a positive number. So the opposite of that would be to make it negative. So I'm going to subtract it to the other side, and I'm going to subtract it from the 7x. Okay, so 7x minus 3x is 4x, okay? The variables don't disappear. Just because you had x minus x doesn't mean the x's go away, all right? Look at it this way. If I had 7 x's, 4, 5, 6, 7, and I subtracted out 3 x's, right? It was 3, yeah. 3 x's, 1, 2, 3. So those all go away. How many x's do I have left over? I have 4 x's left over. So that's why your variables never disappear when you're adding or subtracting. Now when you're multiplying or dividing, that's different, okay? And that I'll reserve that for, I'll do that in this video. Well, why not? I'll show you at the end of this example. So here I have 4x, and then anything you don't deal with just carries straight down. So 4x minus 13 will equal 29. Okay, so I have all my x's on one side. Check. The second step I said was to add or subtract all the other numbers that don't have an x with them to the opposite side. So this minus 13 needs to go. So I'm going to plus 13 over. And the reason why I'm looking at that minus 13 instead of the 29 is because that minus 13 is on the same side as that 4x. So if it's on that side with an x, it needs to go. So the 4x carries down. I have 4x equals, and let's see, 29 plus 13 is 42. Okay? And now, how do I get rid of the 4 by the x? Remember, a number written next to a letter is multiplying. So that's saying 4 times x. So the opposite of 4 times x would be to divide by 4. Okay, and you're going to leave the x behind. Don't divide each side by 4x. Okay, so if you divide it by 4x, that will be like this. This is what I was talking about earlier. So if I did 4x divided by 4x, remember, that's like saying 4 times x divided by 4 times x. Anything divided by itself is 1. So 4 divided by 4 equals 1. Okay? And those would cancel out. X divided by x equals 1. And so by canceling out, it just equals 1. So it says 1 times 1. So if I did 4x divided by 4x, that would just leave me with 1, because 1 times 1 is 1. Okay? But if I did 4x divided by 4, well, I just had 4 times x divided by 4. So anything divided by itself is 1. So that says 1 times x. and 1 times x is just x, okay? So that's why you just leave the x behind, unless you're trying to get rid of that x for some reason, but in this case, I have no reason to do that. So, because you want your final answer to say x equals something. So this is going to say x equals, and 42 divided by 4, that's going to simplify to 21 over 2, or 10.5. Okay, let's do one more example, and just to be cruel, let's do a lot of fractions. So let's do something like 1/2 x minus 6 equals 23 plus 8 over 3x. All right, so this might look like a nightmare, but the same processes are going to be there, all right? So let's get all my x's to one side. Now, which one's bigger, 1/2 x or 8 over 3? If you don't like fractions, you might just look at me and go, well, look, 8 divided by 3, that number on top is bigger than the number on bottom. So that tells me that that fraction, that number value, is going to be bigger than 1/2 x, because 1 is smaller than 2. So what I should do here is I should subtract the 1/2 x to the other side. And I'm only working with my like terms. I didn't write 1/2 x under 23 or 6 or whatever. You're using like terms. They both have x's, so that's why that moves under the other side. All right, so this is going to say -6 equals 23. And so what's 8 over 3 minus 1/2 x? Now, if you have a graphing calculator, you can type in that fraction and it'll tell you the fraction answer. But if you're trying to do it by hand, you need to do the common denominator. 8 over 3 minus 1/2. Okay, so what number do both the denominators, the bottom of the fraction, what do they both go into? I know they both go into 6, okay? So that's the least common denominator that they both go into. So I'm going to see here, I'm going to write 8 over 3 equals something over 6. All right? So here's how you do this. What's 6 divided by 3? 2. What's 2 times 8? 16. So that's how I turn that one into 16 over 6. The next thing I'm going to write is 1/2 equals something over 6. What's 6 divided by 2? 3. What's 3 times 1? 3. So 1/2 is 3 over 6. So instead of saying 8 over 3 minus 1/2, I'm going to say 16 over 6 minus 3 over 6. Okay? And if you have the same denominators, the same bottom number on the fraction, you only look at the top number. The bottom number will just stay the same. So it's going to equal something over 6. Okay? So what's 16 minus 3? That's 13. Okay, so the answer is 13 minus 6. It's not going to be just 13. It's not like the 6's on the bottom are going to go away. If you think about it, if I have 2 quarters, they're both worth 25 cents. Okay, and 2 quarters, well, let's see, remember, the definition of a quarter is 1/4 and 1/4, because if you have 4 quarters, you make $1. So if I'm holding 2 quarters, that's 50 cents. That's half of $1, right? So 0.50, but let's keep this as a fraction. So instead of writing 0.50, I have 1/2. Okay, let's say I spend a quarter. So I'm going 1/2 minus a quarter. That's 1/4. If you subtracted the tops and the bottom, it would look like this. What's 1 minus 1? 0. What's 2 minus 4? -2. That doesn't make any sense just looking at it. It's like, what's happening there? I had 2 quarters and I took away a quarter. If you have 2 quarters and you take away a quarter, look, I took away a quarter right there. What am I left with? 1/4. So if you just looked at it like this, 1/2 minus 1/4, and then you change it to a common denominator, well, if you have 2/4, that's like saying 2/4, see? So I'm going to write this as, instead of writing 1/2 minus 1/4, I'm going to write 2/4 minus 1/4. And again, if you subtracted the top and the bottom, you'd have 2 minus 1 is 1, and 4 minus 4 is 0. So it says you have 1/0. So again, you've made a mistake because we should just have 1/4 left over. If I have 2/4 and I take away 1, I'll have 1/4 left. So my answer needs to reflect that. So that's why you just look at the tops. So 2/4 minus 1/4, that's 2 minus 1, that's 1. The answer is 1/4. I have 1/4, that's 25 cents. Okay, so that's a very long explanation as to how and why we subtract fractions the way we do. So back to this. This was 13/6. Okay, and so this -6 is all by itself, and that 23 needs to go. So it's a positive 23, so the opposite of that would be -23. And here I have -6 minus 23, so that's going to be -29, and that's going to equal positive 13/6x. Okay, so the opposite thing with a fraction is to flip that and multiply it to the other side. So when you do that, it cancels it. And so I just need to type into my calculator, what's 6/13 times -29? Okay, we're multiplying. So my final answer is going to be -174/13 equals x. So it doesn't matter if it starts with x equals or it equals x. You can always rewrite it. X equals -174/13. It really doesn't matter. But that would be the final answer. If you want to get this as a decimal, I'm going to use squiggly equal signs because I'm rounding. So that means approximately. And it's about -13.38. Okay, either one's acceptable, but if it's a long decimal, which if you're looking at this in the calculator, it is a long decimal, it's better to use the fraction. Okay, so that's it for this video. I hope it was informative. Stay tuned for future videos. Thanks.